Hi, in this video, we're going to continue to talk about operator overloading, and specifically, we're going to talk about equality test. So, if we want to see if two vectors are the same vector, then all we have to do is check if the x components of the vector are the same as each other, and if the y components of the two vectors are the same as each other. Right? So, if we do something like that in our code, we instantiate two vectors. They're both 1 and 2 for the x and the y. And if we do a equal between them, it would tell us they are not equal. So why is that? To understand, it requires us to really dig into the meaning of the two equal signs, or what's called equality test, and exactly what it means for a Python object or class. So remember what I said about all the user-defined classes. They implicitly inherit from the object class, which is kind of the base class for all classes. And the object class actually defines the behavior for the equality test. Now, that behavior is the same as what's called the is test. Now, you probably used the is keyword before, and that the is test returns true if the two names we are comparing, they reference the same instance. So, for example, if instead of instantiating two vectors, if we just instantiate one vector v1 and assign it to v2, then we know that v1 and v2, they both reference the same vector instance, and in that case, v1 is v2. So indeed, it returns true, right? And that is this picture here. However, if v1 and v2, they refer to two different vector instances, then v1 is not v2. And so that should be evaluated to false. So I'm going to bring back these two vectors, v1 and v2, and this should give us false, and indeed it does. Now, there is another name for the is test that is also referred to as the identity test. So, and it returns true only if the two names that it's comparing, they reference the same instance. Or in other words, A is B only if the ID of A is the ID of B. So that's why this one is false. It's two different objects. The IDs are different. And in this case, it's true because the two names, they're referencing the same instance. Now, a real world analogy, if that helps, would be that two persons with the same name, John, but because they're two persons, they are not the same person, so they are not identical. So they would not pass the is test. So what does this have to do with our equality test using double equals? Well, the double equal operator, so it's an equality test, and its behavior is determined by the dunder equal method. Now, because our because our vector class did not define the dunder equal method, and the fact that vector implicitly inherits from the object class, so it inherits from the objects dunder equal method. And the objects dunder equal method's behavior is the same as that of an is test. So that's why in this case, I mean, v1 is not v2, and that's why this returns false. And if we want this to return true, in other words, we want vector 1, 2 to equal to vector 1, 2, we have to override or define the dunder equal method in the vector class. And that's not hard to do. We can just define the dunder equal method, and for the vector class, we compare the x attributes of self and other and the y attributes of self and other. So once we define this done the equal and we run the same code again, now it's the equality test is going to return true because the x and y's of these two vectors, they are exactly the same. Now, what if we are comparing, let's say, v1 and an object of a different type, say just a number, right? Should it be false or should it raise an exception? Well, it depends on your project requirement. So if you want to check for the type, make sure it's the right type, then you can check for the type, and if it's the wrong type, then we can raise it an exception here, right? Or if we simply want to say, hey, v1 is not equal to 3, regardless of the type, right? Then we can simply return false here, and that is a also equally legitimate approach. Again, that depends on your project requirement. Now, if we keep this approach though, then there's an interesting consequence, and that is if we actually compare this to none. Okay, and it's quite often that we're trying to check if a name is none, which is kind of a legitimate value for basically any name, right? Because it just means this name is pointing to nothing. Now, if this were the case, though, this is going to die. The code crashes, and that's generally not good. So, and that's actually one of the reasons that in PEP 8, the Python style guide, that when we're comparing with none, it tells us that it should be using the is test rather than the equality test. So I'm going to change this to is, and hopefully, yeah, that kind of a little warning goes away. So this is good, and it's not going to crash. So, right, this slide says what I just said, that when we're trying to compare something with none, we should say is none rather than equal to none. And it's actually the same for true and false, that we should say something is true or is false rather than equal to true or equal to false. And another reason that you always use is to compare with none is that none is actually an object or an instance, but it's the only instance of the type none type. And yeah, you cannot instantiate another instance of the none type. I will show you that just for the fun of it, that so type of none is going to be none type, and then I can instantiate, you probably think I can instantiate another none. Now, it seems like I could do it, but if you check the ID of this thing that I just instantiate, remember this number, and you check the ID of none, it's the same. So even though we appear to instantiate another instance of the none type, we actually did not. We just get none back. So none is the only thing of its type. So if there's only one thing of this type, then there's no need to do the equality test, right? It's either that thing or it's not that thing. So the only test that makes sense for none is the is test. And that's what this slide says.